Welcome dear friends. In past videos we used a Uno R3 board compatible with Arduino. A Shield W5100 board with Ethernet connection capability. We insert the Ethernet Shield on the Uno R3 board. We place a red LED between pins 8 and G and D. Using a straight-through network cable with RJ45 connectors, of sufficient length, to connect one end to the port on the Ethernet Shield board. And the other end, connect it to one of the RJ45 ports available on the router of our Internet Service Operator. Using a USB cable. With a Type B end. And with the other end Type A. We connect our Uno R3 board. With the USB port of our computer. Using the Arduino development environment, we upload a server program to our Arduino board, which finally allowed us to control the LED wirelessly from our phone on our own Wi-Fi network. Some subscribers have asked me, 1. Does this only work at the local network level of my home or facility? 2. How could I control this LED from any location? Well, this works only locally, but the reason transfers to the security properties of our location's router. Since this device, in its default configuration, blocks all service requests that come from a public network, and does not allow access to our private network. Although we can search on Google, what is my public IP address? We can enter the link, and obtain the IP address of the public interface of our router. If I turn off the Wi-Fi on my phone, and I write this address in my address bar of my internet browser, we will not be able to access the web interface that allows us to control the LED, we will be ignored by the router. This is because, usually, in our private network at home or facility, we do not provide any type of web or network service. On the contrary, from our private network, services are requested from public networks on the Internet, requesting, for example, search services, email services, video on-demand services. By having a web service on our Arduino Ethernet device, the router at our location ignores the requests that come from public Internet networks, allowing only communication within the private network. Unless we enter the router configuration of our location, and perform what is known as a port forwarding, allowing passage from the public interface of our router to the private interface in our home. However, this practice, although it is the simplest and at no cost, is inconvenient in terms of security since we are evidently opening an access door in our private network to the Internet, without any type of control or barrier. So, in this video, we will learn how to control our LED from anywhere on the Internet, but, using a broker service, or intermediary. This intermediary located in the cloud, in this case a broker that uses the MQTT protocol, will allow our clients to connect with each other through the Internet in a secure way, that is, it will govern the communications between our cell phone in this case, which will be our publisher, and our Arduino Ethernet Shield device, which will be our subscriber. To configure this broker service, we will use the AskSensors.com platform on the Internet. We will start the tool for free, joining the free plan for 3 months, and clicking subscribe. To subscribe, we enter the username of our preference, our email, confirming the email, and creating an access password. We accept the terms and conditions. And we send the request. Then we must confirm the email that we registered. We go to our mail service. We enter with our usual credentials. And we look for the email from the sender Ask Sensors, even in the spam folder. We click on Activate the account. Then we enter the platform with our email and password. On the platform, we enter actuator, since it is an LED, or an output device that we want to operate. We click on New Actuator. We put a name for the actuator, and the description of our preference for it. Then we click on Add Module, with which we will add module number 1. And we click on Save. It will take us to the tab with the details of the actuator. Then we enter the Modules tab, and in it, we click on Add a new command. In the type of selection box, we choose Switch, and we place the name Red LED in the title. We leave the rest of the parameters as they are, and click on Save. And we now have access to our control interface for the LED on the Arduino, where we can change the state of the switch. Now we are going to program our Arduino as a client of our broker AskSensors.com. So, on our computer, we open the Arduino software. I leave you this code in a link in the description of the video. Download it on your computer and open it with your Arduino software, code that I have structured, synthesized, and tested, based on the technical documentation of the existing APIs on AskSensors.com, and on which you are going to edit only 3 lines of code. The first indicating the IP address for the Ethernet Shield, in case your router cannot assign one dynamically. If you do not know what the IP address of your network is, you can access the command prompt or the command line of your operating system and enter the ipconfig command. This will give you the IP address that your computer has assigned to your local network. Here you can look at the IP address, which is made up of 4 octets separated by periods. According to the numerical value of the subnet mask, the first 3 octets correspond to the network address, which in this case is 192.168.1, and the last or 4th octet corresponds to the host address, in this case the number 2. In my case I will place the IP address 192.168.1.100, which is used by host 100, which ensures that it is far enough away from the other devices connected to my home Wi-Fi network, which normally use host numbers from 2 to 20. Below in username, we will place the username that appears in the upper right part of our Ask Sensors account. In the next line of code, we will place our username again, and our output API key, which can be found in the details of the actuator in our Ask Sensors platform. We copy it from here, and paste it in the space indicated for it in our Arduino code. In the next line we indicate the pin where we have connected the LED on the Arduino, pin 8 in my case. Since at the top of the code we have included the pub sub client library, which is not included natively in the Arduino software. We go to the library manager. In the search bar we type its name. In the search results we locate the library, and install it. When the installation is complete, we close the library manager and check the code to rule out any syntax errors. Then we upload the code to the Arduino board. If we open the serial monitor of the Arduino software, we can see the control messages sent from the Arduino board, where we can see, of course if we did everything right, that our board has subscribed or connected to the Ask Sensors MQTT Broker. From this moment and with any device connected to the internet, for example, our cell phone, we can enter AskSensors.com. Enter the platform. Enter our access credentials. Enter the actuators module. Enter the actuator of our module 1, which we named LED. And control the LED located on the Ethernet Shield wirelessly, and from any location we are, if we have an internet connection. A special greeting friends, I hope you enjoyed the video. See you in the next one.